Good day everyone, welcome again to another session for MGC. This will be session number 26 for MGC 110 and it is session number 7 for manufacturing. So we will be doing drilling today, and this is under machining operations. We dealt previously with turning. Today we will be doing drilling, and we will then go over to milling in the next session. Today's session will be quick. With drilling, as I have indicated previously, that it has an overlap with boring, but it's a process of making holes or of fabricating or manufacturing holes into solid components. So that is basically drilling. You can have drilling operated on a circular feature or on almost all the shapes that you can think of. Usually with drilling, you will start a new hole, and with boring, you need to increase an existing hole. So drilling will start your hole. You can see over there we have about 0.15 millimeter to 75 millimeters. You can imagine how small is that hole of 0.15 millimeters, and the tool that has to be used for that hole and how it can be manufactured. So you can actually achieve that. Even smaller holes, you can just maybe out of your own interest go and find out the tiniest hole ever drilled. You can use your Google or your any search engine. You'll be able to get an amazing result about the tiniest holes ever drilled. This process of drilling in terms of making holes is rapid and economical. I can already compare it with the other method of boring. However, with boring, you will be going for bigger sizes. The machine that can be used for drilling operation include drill press, which the twist drill will be rotating and the work part will be stationary. Otherwise, if you have if you have to drill on a center of a cylindrical component, operating it using the method of turning, you can have your component rotating and your drill bit stationary. Twist drill, in this case we are referring to your typical drill bit. Most of us should be aware and familiar with the tool drill bit. So otherwise, if you don't know what that is, you can just do a simple Google search, and by so doing you will be actively learning, because you'll see pictures of what we are talking about. As I indicated, drilling, it creates round holes in a work part or in a component, and boring, which we dealt with in turning, is only used to increase holes. And you also have the cutting tool called a drill, or you can call it a drill bit. Usually this tool we refer to it as a drill bit. This is a drill bit. Okay, this will be rotating and it will be allowed to move in and out as you'll be operating onto the workpiece or your component. This is your typical twist drill or a drill bit. Over here, this is the side where you hold it. For this particular one, you'll be using a shank, which is a little bit taper, but otherwise you can have it straight. Most of them are straight in the smaller range size. And when you drill in smaller sizes, maybe I just highlighted this. If you want to drill smaller holes, you can just use the small drill bit with the size that you are looking for directly. So if your holes become bigger or are becoming now bigger, you need to use progressive drilling procedure, which you can start with a small drill bit and increase as you go further up to the size that you are looking for. That will be very helpful for you. And drill bit, we have a few terms that surround the drill bit. That will be the diameter, that will be the hole. You can measure it over here. Otherwise, it's possible for you to measure it on the fluid plate. So you have cutting edges. There's two. There's one over this side and there will be one over that side. So you have those two. Chisel edge, that will be the tip, the very tip. And this here, it's a hole which is, according to how it is manufactured, this hole here, the fluid hole, is there to remove your material as you are drilling. So it looks like it's twisted. So once you go into the material with the tip, the material that you are cutting will be coming out at the top, depending on how deep is your hole. So the drill body, that is the length that you can achieve. Otherwise, any length between this and this, you can achieve that. And then you have a drill bit angle there, a pointer angle, and this also determines which type of material you can drill with this drill bit. you have different drill bit for different materials, and speed also plays a very important part. The rotational speed of your drill bit also plays a very important part when you're doing drilling. Otherwise, the other important factor will be the material properties of the material that you are drilling on. That will also play a major important role. So with enough experience, you should know the tricks around drilling, such that you know when it's this material, you'll be drilling at this speed, and you'll be using this type of drill bit. If you need a cooling liquid to cool your drill bit while you are busy drilling, if you don't need that, if you need a cutting fluid or a cooling liquid, you will also have this out of experience. Otherwise, you can from theory just get the basics, but you will get to be conversant with applying them when you are actively involved in the procedures which involve drilling or whatever machining operations that you will be working on. Okay, we have two types of holes that you can achieve: through hole and blind hole. So through hole will be a hole that is all the way through the thickness of the material. Through hole will be the hole that will be drilled all the way to the other side, and the blind hole will be a hole that you drill but it doesn't go onto the other side of the material. This is a blind hole. This will be a through hole. The operations that you can perform which are closely related to drilling: you can do reaming. This will be an operation you perform when you need this surface to be smooth or to get it to a perfect size. Sometimes when you're doing manufacturing, you really need your size to have your hole to have perfect dimensions. Then you will use reaming. It will clean the hole and get it to a perfect size. And tapping. With tapping, you will be operating on a material so that you can form to come up with threads. Threads, we use them for screwing, and that is another mechanical attachment method that is used mostly in the industry for components that you want to manufacture and dismantle on a later stage, using mechanical mating by form of bolts and nuts. Threads are involved in that. You have different types of threads applicable in different type of industries and in different regions around the globe. So that is another thing that you just need to be aware of. Counter boring. When you're doing counter boring, maybe you want to flush your bolt into the material. You have those bolts that you need to use Allen key. So with that, you will need with that type of a bolt, you need to have a counter bolt hole for your bolt. So this will be the root of the bolt, but the head will be up here, but it will be flushed into a material, so you can just come and put a flat material on top of that bolt. And this just as an example that I can think of out of my head now. Continue with the other operations. You have countersinking. On the countersinking, you can think of those screws with triangle heads. So you'll countersink your hole so that they can flush in as well. Center drilling. This is just to get the exact point when you bring in your drill. So center drilling is just to get your center of the hole where you will do the drilling. So a center drill is used to locate your point of drilling. It's advisable to use this method, and then your drilling will come and get that hole right where it should be. Spot facing. Spot facing is an operation where you just make your surface very, very level with that tool. Usually you'll use a drill press. So this is just a bench. This the table. You will be using this table. You will be using it to hold your parts, spindle, drill bit, and then you have adjusting head for tapping into the material and going up. This is the power source. Okay, drill press. So this is another schematic of drill press, typical, which you can find Ryobi. Otherwise, you will get to see another method using a milling machine. But the milling machine is just a bigger machine. You have another one, a radial drill press. So you have another one, a radial drill press. This one is bigger. You can use it to drill onto bigger components. So this one you can use it to drill on bigger components. It can move in all three dimensions. It can go up and down. It can go in and out of the page. It can go left or right of the page. That is three-dimensional. And with advanced machines, you can even put this head at an angle so that you can drill holes in this direction rather than just drilling straight down. Otherwise, you can change the head, this head. You place your components facing the drill bit in the angle that you need. Work holding on the drill presses, there are a few things that you can use. Vise, just check how does a vise look like, but it's a 2-jaw holding component that is used for holding onto something very tight. It's a mechanical power transmitting jaw, but just look into what is vise. Fixture, these are fixture, work holding device that is usually custom and designed. So fixture is another device which you can use to hold onto your piece, but it's manufactured specifically for certain components. So that is fixture. Drill jig, similar to fixture, but also provides a means of guiding the tool during drilling. So you can also check on a drill jig. Other drilling machines, you have gang drill. Gang drill is just having a drill presses laid out in sequence of the type of hole that you need. Let's say you need a 20mm hole, you might have maybe 6, then 10, 15, then 20. Or you might have 6, 11, 16, then 20, something like that. But they will be lined up nicely that you hold this one down. When you're done, you take your component, you put it onto the other machine, take it down, just like that. That will be good for you, instead of using one drill and changing the drill bits every time you need to change the hole size. Therefore, you might just want to use a gang drill for that. Otherwise, the catch is that if you have several holes that you need to punch on your component, you need to clamp it down and clamp it out. But there are devices that you can use that will help you to hold your component very quick and very easy. So numerical control drill is your CNC drill. Just look into it like that. It's a CNC drill. It knows what to do. The speeds are numerical control. It's automated, this one. Let's think of it as an automated. For those of you who don't know what CNC is, just go and say CNC machine. You can have a lot of CNC machines that are used for different procedures, for drilling, milling, turning, and others. Engineering analysis for drilling, the equations that we will be looking at are famous as speed and rate. We know how these two came about. And then you have the material removal rate. There is our material removal rate. Drill point angle theta will be this whole angle here. T will be the thickness of the material. A will be the approach, and theta will be the angle of the two cutting blades or cutting edges. D will be the diameter. T plus A, total distance that the drill must move to create the complete hole for through holes. T plus A, I will explain. You need it. If you stop before this tip is out, you are going to have a hole that is at the end will have a cone shaped exit or end of hole. Otherwise, you need to go all the way out. D, total depth of the hole up to the end of the tip of the blind hole. To calculate the time, you will use this equation if it's a through hole, and then if it's a blind hole, you use this equation. You have here one example. You can go through this example and it will be discussed during consultation hours. There is the solution, and we are done.